Good day, students. You are welcome to your favorite YouTube channel. Today we'll be solving paper 2 of your Chemistry 0620. Yes, your 2023 February March IGCSE. Okay, and you'll be learning all you need to know in order to make an A star. This video suits students that will be writing both the extended exam and the core exam. So please ensure you watch from beginning to end. This is all we're doing today, okay? And then we're going straight to the beginning. But before we start, we want to look at all you need to know in order to make excellent grades. If you are writing any IGCSE chemistry exam, you must know these chemicals. Please, if you do not have any of these offhand, just try to memorize this so that you know each of them. This is caustic soda. Sodium hydroxide is your caustic soda. Lime water is calcium hydroxide. Your soda ash is sodium thiocarbonate 4 and is also referred to as slake lime. Then limestone is CaCO3, calcium thiocarbonate 4. Please try to memorize all these chemicals and know the chemical formula. So if it comes out in your exam, you'll be able to use it to respond. Your exam, they won't give you this CaCO3. The question might just talk about limestone, okay? When you start solving the question, you meet some of this, okay? And we don't know which ones you'll be meeting in your exam. That's why it's, to be on the safe side, just try to memorize all of this. You get it? Good. There are just 8 of them. NH3 is ammonia, and whenever you hear ammonium ion is NH4 with a charge of +1. This is ammonium ion, while NH3 is ammonia. Sulfuric acid is your H2SO4 and is also referred to as your tetrasulfate 6 acid, tetraoxosulfate 6 acid. HCl is hydrogen chloride. Hydrogen chloride is a gas. But when you bubble this hydrogen chloride gas, if you bubble it through water, then it will be dissolved in water. And once hydrogen chloride dissolves in water, the resulting solution becomes aqueous hydrochloric acid. Take note that hydrogen chloride does not possess any property of acid, okay? It cannot turn, it has no effect on litmus paper. You get it? Good. While HCl is a hydrochloric acid which possesses the properties of an acid. Now that you know all of that, okay, another thing you also need to know is your electrochemical series. Of course, the periodic table will be given to you, but the electrochemical series will not be given to you. So to be on the safe side, just try to understand the series, okay? The most electropositive ones are on the top: lithium, potassium, rubidium, calcium, francium, calcium, sodium, magnesium, potassium, sodium, magnesium. So on the electrochemical series, this is the electrochemical series. But sorry about this, sodium comes before calcium on the electrochemical series. Sodium comes before calcium. Okay, so you should have sodium here, Na. Sodium comes before calcium on the chemical series. So just try as much as possible. You can Google it, Google the chemical series, so you have it offhand, so you don't make any mistake. Okay, so when you get to the exam hall and you meet questions that would involve you using the chemical series, you don't lose marks on that. The chemical series will not be given to you in your exam hall. So these are for the positive metals, okay? The electropositive metals, that's the metals have positive oxidation number. Also for the, okay, yeah, that's the potassium, sodium, calcium. Okay, this is just few of it. The one I pasted there is more complete. So potassium, sodium comes before calcium, and that's what I fixed here. Sodium comes before calcium, then magnesium, aluminum, and the rest. While for the negative ions, we have fluorine, tetraoxosulfate 6 ion, thiazonitrate 5 ion, chlorine, bromine, or these halogens, chlorine, bromine, iodine, then you have hydroxide ion. So it's very important you understand all of this. If possible, have it offhand. In fact, it is very good you have it offhand. If you can do that successfully, then nothing can stop you from making an A star, okay? So with the assumption that you have this offhand, if you don't have it offhand, please go back to where it is and pause that part of the video and study it, okay? Please, if you have any review on this video, please say it on the comment section so I can improve subsequent videos I'll be making. Now let's go straight to question number 1. Substance M is a solid at 30 degrees Celsius. So at temperature 30 degrees Celsius, let's assume this is 30. At this temperature, the substance is a solid. Okay, it's fine. Let's go. Between, sorry, the substance is heated to 80 degrees Celsius and its temperature measured as it cools down to room temperature. So it was heated till its temperature became 80 degrees Celsius. Then we left it for its temperature to reduce. Okay, temperature continues to reduce with time. The cooling curve is shown. Now this is the cooling curve. Between which times is substance M freezing? When can we consider a substance to be freezing, a substance that has this cooling curve? Take note that the question told us that it was a solid at 30 degrees Celsius. So here it was a solid. So when you heat the solid, you keep on heating it, the temperature begins to rise, okay? At this time, what is happening? Here, the temperature stops rising, okay? So the heat you keep supplying was used to melt this substance. You get it? Yeah, that's latent heat or fusion. You used to melt it. And after melting it, it became a liquid. Then you keep heating it, the temperature of that liquid began to increase. Then from 80 degrees Celsius, now if you allow it to cool, the cooling curve, the liquid began to cool, the temperature was reducing until at this point, then the temperature of the liquid stopped reducing and it started freezing. So this is the freezing point, okay, or the melting point. So after that, then it became a solid, then the temperature of the solid then continue to reduce further and further and further. So the point we are making is that from here, the substance was melting, or yeah, but since we are interested in reduction in temperature, okay, for the cooling phase, for the cooling procedure, okay, the process of cooling, this stage is referred to as freezing. Yeah, so what happened during melting, the same thing happens during freezing, okay, good. So QR is when we have freezing. Between which time is the substance freezing? That's QR, Q to R, that's option B. Option B is the correct answer to question number 1. We go straight to question 2. Which gas has the fastest rate of diffusion? The gas with the fastest rate of diffusion is the gas with the least relative molecular mass. Argon, what's the relative molecular mass of argon? So you have to know the relative molecular mass of each of these. Okay, so for argon, we have to know the relative molecular mass for C2H4, sorry, C2H6, that's ethane. What's the relative molecular mass of carbon? Carbon is 12. 12 times 2 is 24. Then hydrogen is 1. 1 times 6 is 6. 24 plus 6, that gives us 30. So C2H6 is 30. HCl, hydrogen is 1. Chlorine is 35.5. 1 plus 35.5 will give us 36. 36.5 rather. Yeah, so this will be 36.5. H2S, hydrogen is 1. Sulfur, do I remember sulfur? Anyway, H2, hydrogen is 1. 1 times 2, okay, because of this 2 here. 1 times 2 is 2. Then you add it to S. So H2S will be what now? So we have to know the relative molecular mass of each of them. We have to look for this. Let's go and look for argon and then look for sulfur on the periodic table. So we go to the periodic table. Periodic table will be given to you in your question paper. So you look for argon for potassium, calcium. Argon should be here. Yeah, this is argon, and relative molecular mass of argon is 40. Okay, then where is sulfur? Sulfur is 32. Argon is 40. So let's go back there. Argon is 40. Then sulfur is 32. So 32 plus H2 is 1 times 2. H2 is 2. 2 plus 32, this will give you 34. So which of them has the lowest mass? This is the one that has the lowest mass, and this is the one that will have the fastest rate of the diffusion. Okay, yeah, the one with the least relative molecular mass will diffuse fastest. Let's go to question 3. There are 2 stable isotopes of bromine. The mass number of isotope 1 is 79. The mass number of isotope 2 is 81. Which statement is correct? Number 1, isotopes have the same number of neutrons. Then the concept of isotopy is that a substance has the same atomic number but different number of neutrons. So this one is not correct. Isotopes have different chemical properties. Isotopes should exhibit the same chemical properties. It's just that they have different mass number or number of neutrons. Isotopes have different number of protons. No, it's only the number of neutrons that is different. They have the same number of protons. The isotopes have the same number of outer electrons. Yes, the outer electrons determine the chemical properties of the element. So they have the same number of atoms electron. Why? Because they have the same number of protons. Number 4. Which statement about ions and ionic bond is correct? Bromine atoms form negatively charged bromide ions. Yeah, well, bromine and bromide ion will be Br negative. Yes, that is correct. Let's look at the rest. Ionic bonds form between elements in group 6 of the periodic table. Group 6, they are nonmetals, and nonmetals form covalent bond. An example is oxygen, O2. It forms covalent bond, carbon 4 oxide, CO2, covalent bond. Okay, good. So that B is not correct. Okay, let's look at C. Positive ions formed when atoms lose protons. Positive ions are formed when atoms lose protons. No, first of all, an atom cannot lose proton. Yeah, an atom can only lose electron, and when an atom is losing proton, that's radioactivity, and we don't consider an ion to be formed during radioactivity. Okay, good. So potassium iodide contains negatively charged potassium ions. Potassium iodide negatively charged. No, the oxidation number of potassium is +1. Yeah, so potassium iodide cannot contain negatively charged potassium ions. It can only contain positively charged potassium ions. And even in this case, if let's assume an atom even successfully loses proton, okay, then the atom will become the ion will be negatively charged. Yes, when you are removing positive charge from something, then the resulting charge will be negative charge. So only A is correct, okay, in this case. So we select option A as the correct answer to question 4. Let's go to question 5. Part of the periodic table is shown. Now, part of the periodic table is shown here. So this is the part of the periodic table. And then the question says, which type of chemical bonding is present in the oxide of F and in the oxide of G? Oxide of F, you see this is group 1, group 2. Group 2 elements, they have oxidation number of +2. So it means we have F. Group 2 elements, they have oxidation number of +2. That means we are expected to have a F2 positive, right? Now, F2 positive is now reacting with oxygen. And oxidation number of oxygen is 2 minus. Okay, so when F2 positive reacts with O2 minus, what will you have? There will be transfer of electrons. Okay, yeah, so the 2 electrons of the oxygen will be transferred to the F. Okay, with the assumption that we don't know what F is. So you have FO, yeah. So this is an ionic bond because there is transfer of electron. There is transfer of electron. Then take note that F is in group 2, is a metal. Yeah, so oxides of metals, they are formed by ionic bonding, or either you call it ionic bond or you call it equivalent bond. Then now look at G. G is on group 5. Sorry, G is group 6. Yeah, G is on group 6 of the periodic table, and elements in group 6, they have an oxidation number of -2. Yeah, so we have G2 minus. Okay, it reacts with oxygen 2 minus. Okay, so oxides of non-metals, they are formed by covalent bond. Yeah, yeah, and this will form GO. A typical example is carbon monoxide, CO. Yeah, so that's it. So this is formed by covalent bond. Non-metals form covalent bonds with oxygen, while metals form covalent bond with oxygen. So the first one of F, an oxide of X, sorry, non-metals form covalent bond with oxygen, while metals form ionic bonds with oxygen. So an oxide of F will be formed by ionic bond, while an oxide of G will be formed by covalent bond. So that makes C the correct answer to question number 5. We go straight to question 6. Question 6. Elements X and Y react to form a compound. Element X loses 2 electrons and element Y gains 1 electron. If element X is losing 2 electrons, that means the oxidation number of X is 2 plus, right? Good. Then element Y gains 1 electron. So that means the oxidation number of Y will be -1. Yeah, when something gains an electron, then it has gained a negative charge of -1. Okay, so now when these two react, this is what happens: exchange of oxidation number. So we have x, this minus here simply means minus one, right? Good. So the one comes down here, that will be x1. Then the two up here comes down here, that will be y2. X1, y2. Okay, that can easily be written as xy2. That's it. So that's what we are expecting. Xy2. Yeah, that's it. And charge on x will be plus 2. Of course, charge on x is plus 2. Charge on y is minus 1. Y will be minus xy2. That makes B the only correct answer to question 6. Let's go to question 7. Which statement about graphite explain why it is used as an electrode? Graphite, that is the only state in which carbon can exist and they have free electrons for conduction of electricity. Yes. So graphite is only form of carbon that can conduct electricity. Do not forget that carbon can exist in form of graphite. It can also exist in form of diamond. Yeah. It contains ions. No, it has great covalent structure. No, it is a metal. Carbon is not a metal. Okay. Graphite is not a metal. It has mobile electrons. Good. So that makes D the correct answer to question 7. We go straight to question 8. Methane, CH4, bonds in air to form carbon dioxide and water. What is the balance equation of this reaction? Okay, balancing chemical equation, methane is CH4. Okay, methane is CH4, a gas. CH4 gas reacts with, okay, methane burns in air. If it is burning, that's combustion, and for combustion to happen, then oxygen gas must be involved. And during combustion, um, greenhouse gases, carbon dioxide will be produced. CO2 is a gas, okay. Then since it's a combustion that involve hydrocarbon, then water will be produced. Water, a liquid, H2O liquid, water vapor. Okay, so that's it. Sorry, water vapor is a gas, please. That's water indication state. Yeah, so now we balance this chemical equation. C occurs once here, C occurs once here, yes. Oxygen O2, oxygen O2. There's another oxygen here. How about hydrogen? Hydrogen is 4. Here, hydrogen is 2. So in order to balance it, you can put 2 here. Okay, so let's put 2 here. Okay, so hydrogen is 4 now. Here, hydrogen is 4. Carbon is 1. Carbon is 1. Oxygen is 2. Oxygen is 1, 2, 3, 4. 2 times 1. 2 times 1 is 2. So 2 plus 2, 4. Oxygen is 4 on the right hand side, while oxygen is still 2 on the left. So if you put a 2 here, oxygen becomes balanced. So this should be the balanced chemical equation. So where do we have this? That's option B. Yeah, that makes B the correct answer to question 8. Let's go straight to question 9. The equation for the thermal decomposition of sodium hydrogen carbonate. Sodium hydrogen carbonate is shown. Okay, it's from sodium carbonate 4 and water and carbon oxide. Yes, um, sodium hydrogen carbonate. Yes, sodium carbonate 4. Carbonate 4 is a general property among carbonate 4. They can be decomposed on heating. The relative molecular mass of sodium hydrogen carbonate NHCO3 is 84. The relative molecular mass of sodium carbonate Na2CO3 is 106. In an experiment, 2.1 gram of sodium hydrogen carbonate is heated, but not all of it decomposes. All of the carbon dioxide is collected and measured at room temperature and pressure. The total volume of carbon dioxide produced is 0.21 dm cube. The volume of 1 mole of gas at room temperature and pressure is 24 dm cube. Which statement is correct? The mass of sodium carbonate produced is 0.93. The mass of sodium carbonate produced is 1.33. The percentage yield of carbon dioxide is 10%. Percentage yield of carbon dioxide is 50%. Okay, for us to get percentage yield, we must know the expected yield, and then we can now calculate the actual yield. Okay, so how do you know the expected yield? From the equation of reaction, okay, we can get to know the expected yield. But did you get the actual yield? Okay, in the experiment, the total volume of carbon dioxide produced is 0.21. So we have the volume that was actually produced. Can we get the expected yield from this reaction? Okay, so let's start by getting the first thing, the easiest thing to get. That's mass of sodium carbonates, mass of sodium carbonates produced, yeah. So when we get the mass of sodium carbonate 4 produced, when we check it, if it does not correspond to any of this, then we proceed to calculate the percentage yield. How do you get the mass? Let's see. Look at the equation of reaction. We have 2.1 gram of sodium hydrogen carbonate is heated. Not all of it decompose. The total volume of carbon dioxide produced is 0.21 dm cube. Now let's write the balanced chemical equation. Not balance, the chemical equation is balanced. Let's write the molar relationship. 1 mole of carbon dioxide is produced during the decomposition of 1 mole of sodium hydrogen carbonate 4. This is for what? Sodium hydrogen carbonate 4, yeah. Yeah, when 1 mole of sodium hydrogen carbonate 4 decomposed, 1 mole of carbon dioxide was produced. Actually, by looking at this equation of reaction, this is supposed to be 2 moles. So 2 moles of sodium hydrogen carbonate 4 produce 1 mole of carbon dioxide. Now, take note of this. Our point of interest, we are interested in either the mass of carbon dioxide produced or percentage yield of carbon dioxide. Okay, so now we are interested in what is happening to the carbon dioxide produced. So what else do we have here? We have the volume of 1 mole of a gas, the total volume of carbon dioxide produced is 0.21. We have the volume of carbon dioxide produced, and then we also have that 2.1 gram of sodium hydrogen carbonate 4 was heated. Now, so what will you do here? Since we are interested in the mass or the percentage yield of carbon dioxide, since our focus is carbon dioxide, then we need to know the number of moles of carbon dioxide that will be produced, right? Good. But we cannot find the number of moles of carbon dioxide that will be produced without determining the number of moles of what? Of the sodium carbonate 4 that will be produced. What do I mean by that? So what I'm actually saying is that if you look at this, we are interested in the mass of sodium carbonate produced, right? Yeah. So the mass of sodium carbonate produced or the percentage yield of carbon dioxide. Okay. Now, we cannot determine the mass of sodium carbonate produced without knowing the number of moles of sodium carbonate. Okay. So we also interested in number of moles. From this balanced equation, the number of moles of sodium carbonate that we produce from 2 moles of sodium hydrogen carbonate 4. You see, from 2 moles of sodium hydrogen carbonate 4, we get 1 mole of sodium carbonate 4. We also get 1 mole of carbon dioxide. We are not really interested in water, so let's ignore it for now. Okay, good. So, how do you get the number of moles? You know, the volume of carbon dioxide produced at room temperature and pressure is 0.21. And then we have the expression, number of moles is volume divided by molar volume. Okay, take note that the molar volume of every gas at room temperature and pressure is 24 mole per dm cube. Okay, good. And the volume produced in this case is 0.21, right? Good. So we have the number of moles of carbon dioxide produced as the volume. So number of moles of carbon dioxide produced now will be the volume we have, which is 0.21, divided by the molar volume of every gas, which is 24 dm cube. So if you divide 0.21 by 24, what will you get? Let's check that out. 0.21 divided by 24. I don't need to do that. 0.21 divided by 24. This gives 0.0087. 0.0087. Okay, so 0.00875. 0.0088 is good enough. Yeah, so this is what we have as the number of moles of carbon dioxide. Now look at the balance equation of reaction. If 1 mole of carbon dioxide is produced, automatically the number of moles of sodium thiocarbonate 4 produced is 1. Okay, therefore, if 0.0088 moles of carbon dioxide is produced, then that will also be the number of moles of sodium thiocarbonate 4 that will be produced. Okay, because looking at the balance equation of reaction, the number of moles of carbon dioxide produced is equal to the number of moles of sodium thiocarbonate 4 produced. Okay, so number of moles of carbon dioxide produced is 0.0088. Therefore, number of moles of sodium thiocarbonate 4, number of moles of sodium thiocarbonate 4 that we produce will also be number of moles for this one will also be 0.0088. So how do we get the mass from here? Do not forget the expression number of moles is mass divided by relative molecular mass, okay, molar mass. And if you cross multiply from here, we have the mass is number of moles multiplied by molar mass. What are we talking about? We are talking about sodium thiocarbonate 4. And what's the molar mass of sodium thiocarbonate 4? Molar mass of sodium thiocarbonate 4 is 106. Okay? So if you multiply the number of moles, what's the number of moles? We already got the number of moles as 0.0088. Yeah. Why? Because the number of moles of sodium of carbon dioxide is equal to the number of moles of sodium thiocarbonate 4. That's why we are picking 0.0088 as also being the number of moles of sodium thiocarbonate 4. So you multiply 0.0088 by our relative molecular mass of NaCO3, which is 106. So when you multiply those two, what will you get? We will multiply our answer here by 106. This will give us 0.9275. And do we have that here? Yeah, that's approximately 0.93. That's the mass of NaCO3, sodium thiocarbonate 4. So this one is correct, okay? Since our answer here is correct, then you don't have to go ahead to calculate the percentage yield of carbon dioxide. Yeah, that will be a waste of time. Since the first option is giving you the correct answer, then you don't have to try out the other option. We go straight to the next question, question 10. So an electrolysis experiment is done using carbon electrodes. Hydrogen and oxygen are formed at the electrodes. What is the electrolyte? Hmm. An electrolysis experiment is done using carbon electrode. Okay, hydrogen and oxygen are formed at the electrodes. What is the electrolyte? Okay, let's see. Aqueous copper 2 sulfate, aqueous copper CuSO4, that's copper 2 sulfate. Concentrated hydrochloric acid, that is your copper 2 sulfate will dissociate into copper ion, copper 2 plus, and SO4 2 minus, right? Okay, let's take the other one. Concentrated hydrochloric acid, since it's concentrated hydrochloric acid, then the hydrochloric acid will take precedence over the hydrogen and OH minus ions. So this one we just focus on, since it's concentrated, we just focus only on the hydrogen ion and the chlorine ion. We won't concern ourselves with the water that is present. Okay. Yeah, you know very well that hydrochloric acid means HCl aqueous, right? And this simply means HCl gas that you bubble through water. Okay, so whenever you hear hydrochloric acid, that simply means there will be hydrogen ion, there will be chlorine ion, there will be also, due to this H2O, there will also be H plus, and there will also be OH minus. Okay, so these are all the 4 ions that will be present in your concentrated hydrochloric acid. But since it's concentrated, that means the concentration of these ones is higher than the concentration of this one. So we don't have to bother ourselves about this one. We can only focus on those two. It's clear, right? Of course it is clear. Let's go. The next one is dilute aqueous sodium chloride. So now that we have so we don't have to bother ourselves about hydrogen and hydroxide. Just these two are enough in talking about option B. Now we talk about option C. In the option C, the electrolyte they mentioned here is dilute sodium chloride. Now, sodium chloride, dilute sodium chloride, that is sodium chloride mixed with water, okay? And that simply means sodium chloride mixed with water, okay? So what are the ions that we present here? You have sodium ion, we have chlorine ion, Cl minus, then due to the water, you have hydrogen ion, then you have OH minus. Then the last one is potassium, molten potassium oxide. Then potassium oxide, K2O. Yeah. That will just potassium ion and yeah, when this one dissociates, we have O2 minus. Okay, so and we are told that what was formed at the electrode, an electrolysis experiment is done using carbon electrodes. Hydrogen and oxygen are formed. So which one will cause the formation of hydrogen and oxygen? You know, in this case, we don't have hydrogen and oxygen here, so it definitely can't be this one. Here, only hydrogen and chlorine is produced here. It definitely can't be this one. In this case, only potassium and oxygen, it can be this. But in this case, we have all of this, okay? Then we now consider the position of each of these ions on the electrochemical series. Yeah, we consider the position of each of these on the electrochemical series, okay? Since it is dilute aqueous sodium chloride, okay? That means there is hydrogen and hydroxide ion. So what will cause hydrogen and oxygen to be produced? Then, you know, oxygen can be produced. This is the presence of this OH minus, okay? And this is the presence of this hydrogen ion. Hydrogen can also be produced, okay? Take note that the concentration of these ions will be higher than the concentration of this one because it is aqueous. And by the way, if you even consider the electrochemical series, sodium is higher than hydrogen, okay? So sodium will remain in the electrolytes, while hydrogen will be given off. Hydrogen gas will be given off. Yeah, good. So chlorine is also higher than hydroxide ion. So chlorine remains in the electrolyte, while hydroxide would lose this electron and end up producing oxygen ion as a result. You get it? Yeah? Yeah, of course you get that. So that is what happens, and that makes that makes option C, yeah, that makes option C the correct answer to question 10, right? Yeah, let's go to question 11. Concentrated aqueous copper 2 sulfate is electrolyzed using copper electrodes. Which ionic half equation describes the reaction taking place at the cathode? Hmm. At the cathode. What is happening at the cathode? At the cathode, the cations go to the cathode, and the cathode is the what? The cathode is a negative electrode. The cathode is the negative electrode, and the cations are the cations migrate to the cathode, and the cathode is a negative electrode, and the cations will go here. And what are the cations? The cations are the positive ions. So the positive ions migrate to this negative electrode, okay? Sorry, let me just have a deep thought about this. Yeah, that is correct. The cations are the positive ions. So when the cations get to the negative electrode, what happens? They will accept negative electrons, okay? They will accept electrons, which is negative charge. They will accept electrons, okay, and become free metals, okay? Do not forget the positive ions. Of course, metals have the positive oxidation number. So in which case could that happen? Okay, in this case, concentrated. Since it's concentrated copper 2 sulfate, then it won't be the hydrogen that would participate in the exchange of charges. Okay, since it's concentrated copper 2 sulfate, then it should be the copper and the SO4 SO4 2 minus ions that will participate in the exchange of electrons rather. So copper, okay, yes. No, 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 no. Positive ions migrate to the cathode, which is the negative electrode. So this is the this is the most correct one. The positive ions migrate to the negative electrode. They accept electrons, okay, and after that they'll become just copper atoms. And this is very applicable when we talk about electroplating. So in this case, then it is very likely you are using copper to coat a particular metal. Yes, and that is electroplating. So this makes this the only correct answer, only correct option in this question. Question 12. When powdered sodium carbonate and aqueous ethanoic acid are mixed, the temperature of the mixture falls. Which statement about this reaction is correct? When temperature of a mixture falls, what does that mean? Then the mixture looks cold, right? Since the mixture has become cold, then it is trying to absorb heat from the surrounding. So something that absorbs heat from the surrounding, what kind of reaction do you call that? That is yes, something that absorbs heat from the reaction, from the environment. Something absorbing heat is endo because it is collecting heat. Then something that is giving out heat is exothermic reaction. So since it becomes cold, then it's absorbing heat from the environment. Then that is an endothermic reaction. Yeah. So let's see. The reaction is endothermic, yes, and delta H is negative. No, it is absorbing heat. So the change in heat content will be positive because as it is absorbing heat energy from the environment, the heat content will rise. Yeah, so the heat content at the end will be above the heat content in the beginning. So the reaction is endothermic and change in heat content is positive. Yes, that makes B the correct answer to question 12. The reaction is not exothermic, so these two definitely can't be the correct answer. 13. Magnesium powder reacts with excess of dilute hydrochloric acid to produce hydrogen gas. Which statement about the reaction is correct? Magnesium powder reacts with excess hydrochloric acid, aqueous, to produce hydrogen gas. Okay, hydrogen gas will be given off. Okay, yeah, hydrogen will be displaced. It should be magnesium chloride. Okay, the smaller the particles of the magnesium powder, oh, you don't even need the equation. The smaller the particles of magnesium powder, the more slowly the hydrogen gas is produced. No, no, when you are when you are making the particles smaller, then you are increasing surface area, okay? That hastens the reaction because there will be more surfaces in contact. So this is not correct. The higher the temperature, the faster the magnesium powder disappears. Yes, higher temperature hastens collision and it makes the reaction more vigorous. So this is correct. The lower the concentration of dilute hydrochloric acid, the faster the rate of reaction. The lower the concentration of dilute hydrochloric acid, if you are reducing the concentration of the reactant, then the reaction will be slower, it won't be faster. So this is not correct. The faster the magnesium powder disappears, the faster the rate of reaction. Of course, when the reaction is fast, then the reactants will be consumed at a faster rate. Okay, yeah. So the faster the rate at which this one disappears, it means the faster the rate at which it's being consumed. Okay, yeah. So the faster the rate at which it disappears, the faster the reaction. That's also correct. So number 4 is correct. Then number 2 is correct. 2 and 4. That makes option C the correct answer to question 13. We go straight to question 14. The reaction between two aqueous compounds X and Y is slow and exothermic. Exothermic means it gives out heat to the environment. The graph shows how the rate of reaction changes with time. So this is the graph. A student suggests that the rate of reaction decreases with time because number 1, the activation energy decreases. Number 2, the speed of the molecules of X and Y decreases. Number 3, the concentration of both X and Y decreases. Good. So when the concentration is decreasing, then it causes the rate of reaction to decrease. Yes, so that's the correct one. So we have 1 and 2, no. 1 and 3, no. 2 only, no. 3 only, So once the concentration, as the reaction proceeds, the reactants are being consumed, okay? Good. So it's even similar to what we have here. As the reaction proceeds, the reactants are being consumed. So as the reactants are being consumed, then their concentration will drop. So as the concentration of the reactants here drop, then the rate of reaction will be reducing. Okay, so the previous equation, it can also be used to explain this situation. Okay, so the next one, hydrogen reacts with iodine to form hydrogen iodide. Hydrogen plus iodine to form hydrogen iodide. Which statement explain why the reaction is faster when the pressure is increased at constant temperature? When you increase pressure, now look at the reaction here. Hydrogen gas reacts with iodine gas to produce hydrogen iodide. The number of moles of reactant equals number of moles of product. That simply means the volume of reactant will be equal to the volume of product. Okay, now let's go. Which statement explain why the reaction is faster when the pressure is increased? You know, according to this equation, there's no change in number of moles. Okay, and that simply means it's very likely that the pressure of the gas will remain constant. Okay, yeah, it's very likely that the pressure remains constant both from the reactant part and the product part. But how can pressure now alter the rate of this reaction when temperature is constant? At high pressure, molecules are moving faster. Well, that's correct. At high pressure, more molecules have the required activation energy. Well, that also sounds good. At high pressure, the molecules are closer together. Okay, that's also meaningful. At high pressure, the molecules collide more frequently. Now, take note that for a chemical reaction to take place, there must be collision. Okay, and so this place says the molecules collide more frequently. Yes, that is very good and very valid reason. Okay, when the pressure is high, then the molecules will collide more frequently, and that will encourage the forward reaction. That would encourage the formation of products. Okay, so the reaction will be faster. Also, at high pressure, the molecules are closer together. Yes, when for the reaction to take place, these two molecules must come together and engage in a reaction. Okay, yeah. So when the molecules are closer together, then the reaction can take place. If they are far apart, then there will be no reaction between the molecules. So this is also reasonable. Okay, this one, at high pressure, more of the molecules have the required activation energy. Well, pressure does not have any effect on activation energy. Okay, if you are talking about that, we can talk about increasing the temperature. Yeah, you know, when you add heat, when you are applying heat to something, to the substance, then you are increasing the internal energy. Then you are giving it more activation energy. At high pressure, the molecules are moving faster. No, it is temperature that tells us how fast the molecules are moving. Okay, yeah, because temperature is related to the average kinetic energy of the molecules of a substance. Yeah, so this is not valid reason for pressure to affect the reaction. So it's just 3 and 4. That's option D. Question 16. Ammonium sulfate is used as a fertilizer. It is made from ammonia. It is made from ammonia and sulfuric acid. The one, okay, you pick from this option, is made by dash process in which dash is used as catalyst. Which words complete 1, 2, and 3? Let's see. What do you have here? The ammonia, no, not the ammonia. The ammonia is made by which process do you use to make ammonia? Is it here? No, that's not good enough. The ammonia in which dash is used as a catalyst. Okay, do you have the catalyst? So we have to study the production of ammonia here. What are the stages in the production of ammonia, NH3? Ammonium sulfate. Okay, ammonium sulfate, sorry. Ammonium sulfate, NH4, then SO4. SO4 has oxidation number of -2, so it will be ammonium sulfate. So to produce ammonium sulfate, you have to produce tetrodotoxic acid. Okay. Then from tetrodotoxic acid, you react that with ammonia. Yeah, that will be through the contact process. Yeah, you react tetrodotoxic 6. This is what I mean by tetrodotoxic 6 acid, your sulfuric acid. This will react with ammonia. Okay, This will react with ammonia to form your ammonium sulfate. So you start with ammonia, you start with sulfuric acid. Sulfuric acid is produced, the sulfuric acid is made by contact process, yeah, in which vanadium, okay, this should be good enough, but the vanadium 4 oxide is used as a catalyst. Okay, so that's it. Sulfuric acid is made by Haber process. You use iron. No, not ammonia. No, you are not starting with ammonia. You start with the acid. Sulfuric acid is made by contact process. That's how you make the sulfuric acid. Then use vanadium oxide as a catalyst. That's fine. Then from that, then you can react with the ammonia and form your ammonium sulfate. The reversible reaction shown takes place in a closed system at constant temperature. P reacts with J and R to produce S and T. They are all in the gaseous state. When the reaction has reached equilibrium, more T is added. You are adding more of the product. After the addition of T, which other substances increase in concentration? After the reaction is in equilibrium, you are adding more of the product. What is happening? Take note that this is a reversible reaction, okay? When it's in equilibrium, the rate at which the reactants are being consumed to form the product will also be equal to the rate at which the products are being consumed again to form the reactant. So now if you are adding more of the products here, then you are encouraging the reverse direction, okay? So you are encouraging the reaction to proceed in this direction. Yeah. So if you are adding to the concentration of this one, then you are encouraging the formation of P, Q, and R. P, Q, and R only. That should be C. The correct answer to number 17 should be C. Then we move straight to question number 18. Number 18, in which equation is the underlying substance acting as a reducing agent? Okay, so when something is acting as a reducing agent, oxidation, electron loss reduction, gaining electron. Okay, so what we can do here is you can consider the definition of oxidation as the addition of oxygen to a substance, then reduction the removal of oxygen from a substance. Then you can also consider oxidation as the increase in oxidation number of a substance, and reduction as the reduction in the oxidation number of a substance. Okay, so acting as a reducing agent. So what is acting as a reducing agent here is the substance that is being oxidized. Take note that the reducing agent is being oxidized. So which substance is oxidized here? Okay, is this one being oxidized in this reaction? Is this one being oxidized in this reaction? Is this one oxidized? Is it not oxidized? Let's see. So can we say this substance is oxidized here? What's the oxidation number of calcium here? +2. Okay, because oxygen is 2 minus, calcium is +2. And what's the oxidation number of calcium here? It's still +2. Okay, so we cannot say this one is being oxidized. Okay, so is this one being oxidized here? Oxidation number of copper here is +2. Here, oxidation number of copper is 0. So oxidation number has reduced, so it's not oxidized. Oxidation number of carbon here, CO2, carbon 4 oxide. Oxidation number of carbon here is 4. Then this carbon monoxide, okay, or you say carbon 2 oxide. Oxidation number of carbon here is 2. Oxidation number is reduced from 4 to 2. So we cannot say this one is oxidized because oxidation is increase in oxidation number of a substance. So here, oxidation number of carbon is CO is carbon 2 oxide. Oxidation number of carbon here is +2. Okay. In this case, oxidation number of carbon here is +2. Okay, this carbon 2 oxide. Yeah. Then in this case, this is the same thing. Here, oxidation number of carbon here, this carbon 4 oxide, oxidation number of carbon here is +4. So if oxidation number has increased from +2 to +4, so that means this substance is oxidized. And take note that what is being oxidized in the reaction is the reducing agent. Yeah, so since this is oxidized, then this is the reducing agent. Also take note that this is acting as a reducing agent because it removes oxygen from this one. Okay, so it strips this one of its oxygen, and it now possesses the oxygen, okay, while the ion remains without the oxygen. So ion has been reduced because it has lost the oxygen. So those two definitions matches the process that is taking place. Question 19. Question 19. In an aqueous solution reacts with a solid, the products are an alkaline gas, a salt, and water. What are the aqueous solution? What are the aqueous solution and the solid? What's the aqueous solution that can react with a solid and the product will be an alkaline gas? Let's see. Sodium hydroxide, then magnesium carbonate. Sodium hydroxide, NaOH, reacts with magnesium, Mg. When sodium hydroxide reacts with magnesium carbonate, MgCO3, magnesium carbonate 4, what will be produced? Will it produce sodium NaCO3 and magnesium hydroxide? Sodium is higher than magnesium on the electrochemical series. Then CO3 is higher than okay. So this will produce sodium carbonate 4 plus the magnesium hydroxide. Okay, so is it producing an alkaline gas? No. Is it producing water? No. Mg, okay, there's a bracket here. So this is not working. Let's try option B, hydrochloric acid and magnesium carbonate, HCl and MgCO3. Hydrochloric acid, HCl equals solution plus magnesium carbonate, MgCO3. Okay, so chlorine, then magnesium. Okay, so this should produce magnesium chloride plus so it's producing an acid, calcium carbonate 4 acid. Okay, good. So is it producing an alkaline gas? No. Is it producing water? No. It must produce all of these three. So A and B are not working. Okay, so I want to erase what I have here so I can have enough space to try the other two options. Let's see option C. The third one we have here, um, hydrochloric acid and ammonium chloride, HCl equals, sorry, plus ammonium NH4Cl. So what would this produce? HCl, Cl, chlorine. Will there be any reaction here? Or will it be forming HCl and ammonia gas? Yeah, it's produced an alkaline gas, a salt, and water. Will there be any reaction here? Take note that this chlorine, unless you are forming unless this one is dissociating, there shouldn't be a reaction here. And if a reaction is taking place, probably due to some conditions you subject this to, the most you can have could be HCl, and the ammonia will just bubble out as a gas. Okay, so this one is definitely not working. Let's start the last one, sodium carbonate, Na2CO3, sodium carbonate and ammonium chloride rather, NH4Cl. So sodium chloride, this should be sodium chloride plus we have carbonate 4 acid, then we have our ammonium. Ammonium, should it be ammonium carbonate 4? You can have ammonia gas, okay, NH3. Okay, yeah, we can have ammonia gas, okay, yeah. Then sodium carbonate 4 we form reacts with ammonium chloride, okay, to form what would this form? Sodium hydro, oh sorry, this is sodium hydroxide, not sodium carbonate 4. Sorry. This sodium hydroxide. Okay, so it will make sense now. This sodium hydroxide, NaOH, reacts with ammonium chloride. Ammonium chloride. So what would this form? This will form sodium chloride. This will form sodium chloride. Okay. Plus what else do you have? Sodium chloride. Sodium chloride plus do you have ammonium hydroxide? Of course not. What this will form will be NH3, ammonia gas, NH3. Okay. Then the hydrogen there attach itself with the hydroxide water. That's what we were looking for. Good. This is the alkaline gas, ammonia. Okay. And a salt. The salt is sodium chloride. Then water, H2O. Yeah, that makes D the correct answer to this question. We go straight to question 20. Butanoic acid partially dissolves in aqueous solution. Which row about butanoic acid is correct? Butanoic acid. Butanoic acid. Okay. So butanoic acid is an organic acid. Okay. An organic acid is a weak acid. So the pH would not be would be close to 7, yeah, less than 7, but close enough to 7 because it is an organic acid. And organic acids are weak acids. So pH 3, that's far from 7. 5 is good. 5 is good. 5 is close enough to 7. 8 is also close to 7, but is a base, okay? Is a base. So this does not match what we are talking about, okay? We are interested in an acid, but an organic acid. So 5 is a close enough pH for an organic acid. And effects on thermophthalate, of course, turns colorless. That makes B the correct answer to question 20. We go straight to question 21. Copper 2 sulfate is prepared by adding excess copper 2 carbonate to sulfuric acid. Copper 2 carbonate to sulfuric acid. Why is excess copper 2 carbonate added? Copper 2 carbonate with sulfuric acid will give us copper 2 sulfate, CuSO4, plus that should be thiazocarbonate 4 acid. Okay, yeah, that's good enough. So why is excess copper 2 carbonate added? Okay, so why don't you just add the exact amount of the reactants we need? Why do you have to add excess? It's because in reality, all of these reactants is not being produced, okay? It's not being consumed. Yes, so some will be left behind, some will be left behind. So in order to ensure all of the reactants are being consumed, we can have excess of this acid, okay? So that all of these will be end up being dissolved, okay? Good. If you don't have excess of why is excess copper 2? Sorry, you had excess of copper 2 thiazocarbonate 4. Okay, you add excess of copper 2 carbonate to it, okay, in order to ensure that all of the acid will be consumed. Yeah, so if adding excess of this will ensure all of the acid will be consumed. If you don't add excess of this, some acid might not be consumed, and at the end of the day, the products will have acidic medium. And take note that this is a strong acid, and you don't want to have that, okay. You want to ensure, so you always do that in chemistry when you want to ensure one of the reactants is completely used up. You don't want to have excess of that reactant. We don't want to have excess of this strong acid. So we want to ensure it's completely used up. So you add excess of this, okay? So you ensure all the strong acid is completely used up. So this is the product, okay? You might have this acid which is not as strong as this one here, okay, which is still acceptable. So ensure all the copper 2 carbonates as reacted. Why do you have excess? You're adding excess of this to ensure excess of the other one is used up. To ensure all sulfuric acid has reacted. This is the correct answer to question 21. To ensure all the sulfuric acid is completely used up. Question 22. Part of the periodic table is shown. Which element has 2 electrons in its outer shell and 3 electron shells? Well, this is period 1, this is period 2, this is period 3. So these two are likely to have 3 electron shells, okay? Okay, so this for the number of electrons. The period gives us the number of electron shells we have, okay? Good. So this one we have 3 electron shells. Okay, good. Which element has 2 electrons in its outer shell? Now, outer shell, this group 1 element, they have 1 electron in their outer shell. Group 2 elements have 2 electrons in their outer shell. Okay, so this is correct. B and C are correct for 2 electrons. Then C and D are correct for 3 outer shell. So that makes C the only one that meets those 2 conditions. And we shade option C as the correct answer. 23. Elements in group 1 and group 2 show the same trends in their reactions with water and in their density. Which row shows how the properties of barium compare with calcium? So in order to get this done, we have to understand look for position of barium and calcium on the periodic table. So this periodic table, we have calcium here, you have barium here. Ideally, you expect the elements that are at the top of the okay, yeah, you expect the elements in this period one, sorry, this period 2 rather, period 2, period 3, period 4, period 5, period 6. You expect the elements in the lower period, okay, the upper part of the periodic table to be more reactive than the one at the lower part. But no, as for these alkali earth metals, the reactivity comes from the bottom, okay, and it reduces upward, okay. So barium is more reactive than calcium, okay, due to the ease with which the elements at the bottom of this um this group, the ease with which they easily lose their electrons, okay. So the ease with which these ones can lose electron is higher than the ease with which these ones at the top can lose electron. So barium is more reactive than carbon, okay. So that is that is the property of the alkali earth metals. We are in number 23, right? Yeah. So which row shows how the property of barium compared with calcium reacts with water? Barium reacts faster than calcium. Then density is barium less dense? No, density increases downward, so barium is denser. Yeah, reaction is water faster, density of barium is higher. Yeah, because the question says shows how the properties of barium compare with calcium. So barium reacts faster with water. Okay, also barium is density of barium, is it higher or less or high or lower? Density of barium is higher. Why? Because sorry, that's the answer. I shouldn't say that. This density of barium is higher. Why? Because it's at the bottom of that group. Okay. Take note that the relative atomic mass of the element is higher at the bottom. Okay. This one is higher than this one. Look at you can even read it here. This atomic mass of relative atomic mass of barium 137, while that of calcium is 40. So you can see it is far higher. So it's far denser than calcium. So barium is denser and it also reacts faster with oxygen than calcium. Yeah, so that's option B is the correct answer. Question 23. We go straight to question 24. Which pair of compounds show a transition element into oxidation state? What's the oxidation state of chromium here? Cr2O3. The oxidation number of oxygen is -2, okay? So -2 times 3 will give us minus 6, okay? Yeah, -6 divided by 2 is 3. So oxidation number of chromium is 3 here. SO4 2 minus times 3. Okay, so let me just solve it. What's the oxidation number of chromium here? So we have Cr2O3. Oxidation number of oxygen is 3. So we have 2x plus oxygen is -2, okay? So -2 times 3. This should give us 0. So 2x minus 6 should give us 0. So 2x should give us 6. Then x is because 6 divided by 2 is 3. So oxidation number of chromium here is +3. So now to check the oxidation number of chromium here. Okay. So we do the same thing, but we do it with SO4. That's Cr2SO4. So I write that here. Cr2SO4. And there should be three of this. So we have 2x plus SO4. SO4 is always written as SO4 2 minus. So the triazole ion has oxidation number of -2. Okay, multiply by this 3 down here. Okay, so -2 times 3. All of this should give us 0. So 2x minus 6 should give us 0. So 2x should be equals to 6. Divide both sides by 2. X should be equals to 3. So oxidation number of chromium remains plus 3. Did the oxidation number of chromium change? No. But we are interested in when it has two different oxidation states. The oxidation states are the same thing here. So let's look for when the oxidation states are likely to be different. Zinc sulfide, zinc SO4, CuO, CuO3. Okay. Oxidation number of oxygen is -2. Oxidation number of oxygen of CO3 2 minus. It can't be this. So I just want to be quick with this so I don't consume too much time. Okay. I want to be quick with this. Let me try this. Okay, don't let me just conclude without trying. Let me try this. CuO2. Sorry, Cu2O. Oh, okay. Cu2O, not CO2. Let's try option B. Okay. So option B gives us Cu2O. Okay. So that means we have 2x then plus -2 should give us 0. Why did I write this? Because we are interested in oxidation number of copper, okay? And there are 2 atoms of copper here. That's why I wrote 2 times that copper that you're looking for. Oxidation number of oxygen is -2, so we put the -2 here. All of this should give us 0. Yeah, so I put 0 here. So let's go 2x minus 2 should give us 0. So 2x should be equals to 2. Divide both sides by 2. X should be equals to 1. So oxidation number of copper here is +1. Now let's try it out in the second case. What will be the oxidation number of copper here? It's obvious this one will be minus. This one will be 2. Yeah, because this is copper carbonate 4. But let's just solve it. So CuCO3, copper carbonate 4. So we have X plus, this CO3 is always written as CO3 2 minus. That's carbonate 4 ion. Oxidation number, sorry, the charge is -2. So we have -2. All of this should give us 0. So X minus 2 should give us 0. That means X is equal to 2. Oxidation number of copper here is +2. So in this case, oxidation number of copper was +1, and here oxidation number of copper is +2. So this shows copper having 2 oxidation states. That makes B the correct answer. Okay, so let me wipe this off. So that makes B the correct answer. Okay, in copper oxide, oxidation number of copper was 1. Okay, and in copper carbonate 4 or copper carbonate, oxidation number of copper is +2. We go straight to the next question, question 25. Which description is correct? A. A compound of is a compound of copper and zinc. Sorry, which description of brass? Which description of brass is correct? Option A, brass is a compound of copper and zinc. Option B, brass a compound of copper and tin. Option C, a mixture. Brass is a mixture. Brass is not a compound. Yeah, a mixture of copper and zinc. Yeah, it's an alloy. We call it an alloy. An alloy. An alloy is a mixture of metals, not a compound. What is the symbol of the metal used in manufacture of aircraft because of its low density? It's aluminium. Aluminium has low density, okay, and is also strong enough to be used for the manufacture of the parts of an aircraft. 27. Which substance reacts to form hydrogen gas? Calcium and water. Silver and dilute hydrochloric acid. Magnesium and steam. zinc, and hydrochloric acid. I've not been referring to the electrochemical series. Okay, so we have to refer to electrochemical series now. Okay, calcium and water, Ca plus H2O. Now, we try to determine if calcium is higher than hydrogen on the electrochemical series. If calcium is higher than hydrogen, then calcium can displace hydrogen. Okay, yeah. If calcium is higher than hydrogen, then calcium can displace hydrogen in this reaction. So let's look at the electrochemical series. On the electrochemical series, we have lithium, potassium, rubidium, cesium, francium, sodium, calcium. Look at the position of calcium. Now look at the position of hydrogen. So you can see that calcium is higher. Calcium is higher than hydrogen. This is calcium, this is hydrogen. Calcium is higher than hydrogen. That means calcium can displace hydrogen in that reaction. Okay? So we come here and yeah, calcium will displace hydrogen. Okay, so you have hydrogen gas, it will bubble out. Okay, hydrogen gas will bubble out, H2 gas, plus this should be forming calcium hydroxide. Yeah, so this is the displacement reaction. Calcium will be displaced. Okay, so this is correct. This one will form hydrogen gas. How about this one? Silver and dilute hydrochloric acid. Silver is below hydrogen on the electrochemical series. So this one will not produce silver. Okay, I don't want to be writing equation for everything, okay, in order to conserve time. This one cannot form silver chloride because silver is below hydrogen on the electrochemical series. If you look at the electrochemical series, hydrogen is above silver. Hydrogen, copper, mercury, silver. Silver is below hydrogen. So silver is not stronger than hydrogen. It's not more electropositive than hydrogen. So its affinity for participation in a chemical reaction is less than that of hydrogen. So it just remains like this. No chemical reaction will take place. Okay. The next one, magnesium and steam. Magnesium is higher than hydrogen. Steam is just water. Okay, steam is water. Okay, so imagine having magnesium and steam. The magnesium will take place in this reaction. We have magnesium hydroxide, then hydrogen gas will be given off. The last one, zinc and dilute hydrochloric acid. Zinc and dilute hydrochloric acid. Okay, so let's see. Yeah, zinc is higher than hydrogen on the electrochemical series. So there will be a reaction. So we have 1, 3, and 4, which makes A the correct answer to this question. Question 28. Coke. Coke is carbon, of course. Coke and limestone are two raw materials used in the extraction of iron from hematite. Which type of reaction occurs when each substance is heated during the process? Coke, of course, coke is used for what? Coke is used for reduction. Okay, so the coke will um will will extract oxygen, okay, from that ore. Okay, the coke will extract oxygen to form either carbon monoxide or carbon dioxide. Okay, and then what will happen? Limestone, limestone is CaCO3, and during the extraction of metals is taking place in the blast furnace under high temperatures. And all thiazocarbon 4, when they are heated, what happen? They decompose. There will thermal decomposition. When you heat a thiazocarbonate 4, there will thermal decomposition. Okay, it will produce carbon 4 oxide. Okay, then it can produce an oxide of that metal. Yeah. So there will be the carbon, the coke will help in reduction, while the limestone will undergo thermal decomposition. Yeah. So the correct answer to 28 is B. We go straight to question 29. Sorry. We go straight to question 29. 29. Some combustion reactions produce pollutant gases. Which reactions produce a pollutant gas that is not present in clean water? Okay, so which pollutant gas is not present in clean in clean air. Okay, what do you have? Should carbon monoxide be present in clean air? No, it is carbon dioxide we can have in clean air. Of course, we can have water, we can have water, carbon dioxide, of course. Um, Nitrogen monoxide, can you have that in clean air? Of course not, we can't have that. Um, yeah, nitrogen 2 oxide should not be present in clean air. So that is 1 and 4. That makes B the correct answer to question 29. We go straight to question 30. 1 mole of an alkane Y produces 72 dm cube of carbon dioxide when burned in excess oxygen, measured at room temperature and pressure. What is Y? Okay, you know that 72 dm cube, number of moles is volume divided by molar volume, right? So since the volume produced is 72 dm cube, divide that by molar volume of any gas, we get 3 moles. Yeah. So now which reaction will give us 3 moles of what? 3 moles of carbon dioxide. Yeah. So which reaction will give us 3 moles of carbon dioxide? Let's see. We try them one after the other. We try butane, we have ethane, we try methane, we have propane. The propane is C3H C3H8. Yeah, so it's very likely to be propane because you see we have 3 moles of carbon we produce, and propane has C3. So let's start by trying this one. Okay, so if it does not work, then we try the other option. Okay, so that's another technique we can use to conserve time. C3H8. Okay, so 1 moles of alkane Y produces 72 moles of CO of carbon dioxide when burned in excess oxygen. So plus oxygen combustion. So what will happen? This will produce, of course, carbon dioxide will produce, then water vapor will also be produced. Now let's balance this equation. Carbon is 3 here. Let's put 3 here to balance it. So carbon is now 3. Oxygen is 2 times 3. Oxygen is 6. Oxygen is 1 here. Hydrogen is 2. Hydrogen is 8 here. We put 4 here. Yeah, so hydrogen is now, sorry, did I just do that? Hydrogen Hydrogen is 8 here, hydrogen is 2 here. We put 4 here to balance the hydrogen. So hydrogen is now 8, hydrogen is 8, carbon is 3, carbon is 3 times 2. Carbon is 3 rather. Oxygen is 3 times 2, 6. 6 plus 4, 10. In order to balance oxygen to be 10, we just put 5 here. So this balances the equation. Okay, so we have 3 moles of carbon dioxide. That means it is propane that reacts with excess oxygen to give us 3 moles of carbon dioxide. Okay, so if you try the rest of them, I'm sure you won't get 3 moles of carbon dioxide. We go to question 31. The structure of organic compound X is shown. It's an organic compound. What is X? Okay, one. What is X? What do we call this? Is it ethyl ethanoate? Ethyl ethanoate, ethyl methanoate, methyl ethanoate, methyl ethanoate. Why did I call it methyl ethanoate? Now, take note of this. On this carbon atom, that's where we have this. Okay, this itself is the ethanoate. Okay, and this is the methyl group. Okay, so and yeah, that is methyl ethanoate. We can't call it one methyl ethanoate. It is one, then we don't have to put it there. That's under organic chemistry. Number 32. What is the structural formula of the compound formed in the addition reaction of propene with bromine? Propene. Propene is C3H6. Yeah, that's propene. Then plus bromine. Okay, I think because there's a double chain, should there be 2 bromine? There should be 2 bromine here. Let me just draw the structure. propane, C, because there will be H, 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 C, C, yeah, H, 2, 3, 4, H, H. Yeah, this is propane. Now, when you add bromine to this, so one bromine cannot just attach itself to this while this one becomes hanging. If you are breaking this double bond, okay, and you are turning it to a single bond, okay, so as you are adding something here, something must also be added to this, okay. Take note that oxidation number of carbon here is -4, so you have to add also one here. So there will be bromine here, there will also be bromine here. Yeah, so this should be balanced, and that should be this. Then this will produce C, this CH3, this CHBr, this another CHBr, CH2Br. Yeah, that should be option A. Number 32, we have A as the correct answer. We go straight to question 33. Okay, number 33 says, ethanol is produced industrially by fermentation and also by catalyzed addition reaction involving steam. Which role describes one advantage of each process? Okay, fermentation, you can easily perform fermentation, is a biological process. Then also by catalyzed addition involving steam. Okay, let's see. The reactant used is renewable. That's correct. It is a continuous process. Yeah, fermentation is a continuous process. And then reaction involving steam, the reactant is renewable. That's also correct. Yeah, 33. The correct answer is A. Both of them are correct. They would have to waste time in considering other options. Let's conserve time. We go straight to question 34. Carboxylic acids react with alcohol when warmed with an acid catalyst. Which type of substance is formed? Carboxylic acid reacts with alcohol. Carboxylic acid, R, reacts with alcohol. What will be formed? We should be having alkyl or the alkyl or the R group, R, C, O, O, R. Okay, let me just put a distinction here, then put a prime here. Yeah, then what happens to the rest? You are removing one hydrogen here, then you are removing the OH here, then plus water. Okay, so and this process is called esterification. Yeah, how you produce ethers, and that is B. Yeah, question 34, B is the correct answer to that. We go straight to question 35. Nylon is formed by condensation polymerization. Which structure represents nylon? Well, in this case, you just have to study the structure of various organic compounds, and the only correct answer here is option C. Yeah, so you have to just try to understand the structure of various organic compounds, okay? And nylon happens to be one of them whose structure you just have to understand, okay? Yeah, we go straight to question 36. Which structure represents the repeat unit of the addition polymer formed from both one in? Okay, let's see, where can I write? Let's see, both one in. C, 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 C. Both one in. H, 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 H. Then you have H, H, H. Now, repeat units of the addition polymer formed by Boltzmann in. Now, if if you are adding, okay, addition polymer, then you break this bond, then you have another of this, you break this bond too, and then you bring them beside each other, okay? Okay, yeah. So let me just draw what that will look like. Okay, so sorry, I made a mistake here. Okay, look at the number of chains here: one, two, three, four, and number of chains around this one: one, two, three, four, five. So this one should not exist. Okay, so let me remove it. Yeah, so this is what you have. So now during the addition reaction, this double bond here will break. Okay, this one will break, and it will exist as a single chain here, okay, single bond here, and there will be room for others to come in. Yeah, there will be room for more. So let me fix that. So this one will break completely, and it will exist as a single chain here, and then there will be room for more here, and there will be room for more here. And which of these options matches this? Okay, so will it be the room for more be at the two extreme edges? No, the room for more are just two adjacent carbon atoms in the chain. So when do you have that? So one between them, no. Okay, is it like this? Like this? No, no, no. This one is at the edge, this one is at the edge. These two are in the middle. No, no, not two in the middle, two at the edge. So this goes like this. These two are the extreme edge, okay, at the edges, okay, yeah, and these two are the edges. So this is the only one that matches that description. We pick option A for question 36. We go straight to question 37. Question 37 says, okay, 2 grams of powdered calcium carbonate is added to 50 cm cube of hydrochloric acid. Which apparatus is used to measure these quantities of calcium carbonate and hydrochloric acid? Calcium carbonate, how do you measure calcium carbonate? Calcium carbonate is what? It should be in a solid, okay, or at most in the powder form. And if you want to measure, take note that you are measuring the mass. And what do you use to measure mass? A balance, okay? Good. So we use a balance to measure mass, okay? And then you want to measure 50 cm cube of hydrochloric acid. This is a liquid, okay? Yeah, an aqueous solution rather. Good. So you want to measure is in the liquid state. That's what I mean. So you want to measure something that's in liquid state, you are measuring the volume. What do you use? Measuring cylinder. Thermometer, of course not. Okay. So if you don't have measuring cylinder here, you can use the burette. Burette, yeah. You can use the burette. So you can use burette. These two are correct. Okay, of course you don't use thermometer. So it's only in option A that both recommendations are correct. Number 38. The diagram shows a chromatogram obtained from the colors of 3 different suites X, Y, and Z. How many different red dyes are present in the suite? Red, 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 yellow, red, yellow, yellow, red. How many red dyes? We have these two are the same level, these two are the same level. We have 2 red dyes. That makes B the correct answer to question 38. We go straight to question 39. A mixture contains sand and aqueous sodium chloride. Which process are used to obtain a sample of solid sand and sample of solid sodium chloride? Solid sodium chloride. Okay, so these are under the purification technique. Okay, so you have sand and sodium chloride, both of them in a container. What do? The first thing you do, you pour water. Okay, when you pour water, the sodium chloride will dissolve. Okay, then you pour it into a sieve. Okay, this is your funnel. Okay, you have your filter paper here. Yeah, sorry, that just say sieve. You pour it into your filter paper. Okay, so when you pour this dilute, when you pour water, this one will dissolve, the salt will dissolve, okay? So it has the salt, sand, water. Now when you pour it in, your sand will be here, okay? Your sand particles will be here, while this will be a solution, what sodium chloride solution, okay? Solution of salt and water, okay? And then you apply heat to this one, or you sun dry it, okay? And that process is called crystallization. When you sun dry, the water vapor will escape, okay, and you'll be left with pure sodium chloride. So crystallization followed by filtration, no. The first thing is filtration followed by crystallization, correct. You filter out the sand, okay, and then you take it through the process of crystallization to have your crystals left, okay. Then number 40, you see, we already told it. A student tests an unknown compound M. The compound produces lilac flame using flame tests. Also, the compound produces a gas which turns lime water cloudy when dilute hydrochloric acid is added. It turns lime water cloudy, okay, under an acidic medium. Turns lime water cloudy. What is lime water? Lime water, calcium hydroxide, CaOH. So now, something that turns lime water cloudy, what does that mean? That means it is leading to the formation of CaCO3. Yeah, it's leading to the formation of limestone, okay? And that is only possible when your lime water, calcium hydroxide, reacts with carbon dioxide. So when you bubble carbon dioxide, okay, for instance, you have a container that contains lime water, okay. Now, when you bubble carbon dioxide gas, like when you pass carbon dioxide through a pipe and you bubble it through this liquid, okay. So if this liquid was lime water, if you bubble carbon dioxide through it, it will lead to the formation of CaCO3, and this is what has it has the what, that is what turns cloudy, yeah, okay. When lime water turns cloudy, then it's forming CaCO3. That simply means CO2 must be present in the process. A student tests an unknown compound M. The compound produces lilac flame using flame test. Then it produces a gas which turns lime water cloudy when dilute hydrochloric acid is added. Now, what is M? What is M? Is it sodium sulfate? No. Sodium sulfate does not produce lilac flame. Okay. Sodium sulfate does not produce lilac flame. Sodium carbonate. A carbonate is present. That's what I'm saying, that there must be a carbonate present. Okay. Okay. Yeah. There must be a carbonate, okay, produces a gas. So when carbonates are heated, all carbonates fall, okay, whatever this one is, be it calcium, be it potassium, be it magnesium, okay, let's assume it's potassium, be it potassium, all carbonates fall. When heated, they produce carbon dioxide. It is this carbon dioxide that turns lime water milky. It is this carbon dioxide that turns lime water milky, okay. So we know about the carbon dioxide. What about the first element, okay, the metal itself? Through flame test, we are able to detect different metals, and it is potassium that produces this lilac flame. That's the color potassium produces, okay. So we know that potassium is present because of the lilac flame. Then we know that carbonate 4 is also there because it produces a gas. This is the gas that turns lime water milky, okay. Calcium carbonate 4 has the milky color. So that is it. And that is it. That brings us to the end of it. You see how our knowledge of all these chemicals helps us to answer all these questions correctly. Also, we also have to understand the electrochemical series, okay? We have to understand each of the elements in the electrochemical series. You don't have to memorize the periodic table, because the periodic table will always be given to you in the question. Please kindly ensure you subscribe to this channel, okay? Also, give me your feedback on this, okay? If there's anything you want me to work on, okay? If you notice any error, any issue, draw my attention to it, okay? So it can ensure I produce a more quality video, okay? And so also, this is also my first chemistry video, okay? If it's good enough, your comments will encourage me to keep producing more chemistry videos so I don't stick to physics alone. Do not forget, the name of this YouTube channel is Physics for Everybody. Ensure you share this with your friends so that they can study hard and perform well in their exam as well. Do have a nice day. Thank you very much.